This is Geometry Chapter 5, Section 6, in which we will study inequalities in two triangles. Okay. We did inequalities in one triangle a couple of sections back, and we basically boiled down their theorems to say that the bigger side gives you the bigger angle, and the bigger angle gives you the bigger side. Today it's the very similar message. Don't let all the prepositional phrases throw you. Okay? There's a lot of verbiage here to get to a fairly simple idea. And they call this the hinge theorem because they picture a hinge. Something that holds a door together. And the wider you open the hinge, the farther the opening is. The bigger the angle you made means you made a bigger side. So let's hammer through the verbiage, and then we will talk about what it really means. The hinge theorem tells us if two sides of a triangle are congruent to two sides of another triangle, and the included angle from the first triangle is greater than the included angle in the second, that is to say you've opened your hinge wider, then the third side of the first triangle is bigger than the third side of the second triangle. Okay? What it comes down to is a bigger angle makes a bigger side. And the converse also works. If two sides are congruent to two sides, and your third side is longer in one triangle than it is in the other, then your included angle is bigger in the one that had the bigger side. So again, the short version, if you have two sets of congruent sides, so that you're comparing two triangles that are of the same size for part of it, at least, then the bigger angle gives you the bigger side gives you the bigger angle. Okay. Mathematicians, remember, get paid by the word. Sometimes I think they get paid by the syllable. So they have to come up with all these grandiose ways of saying things that could be boiled down a little bit. And I'm guilty too. I just use grandiose for no apparent reason. So let's compare some measures based on what's given to us in a triangle. Okay, we have two triangles, triangle JKL and triangle MPQ. And you'll notice we have two sets of matching sides. We have a 15 to match a 15. We have a 12 to match a 12. So the question is, how does JK compare to MQ? Well, it all depends on the angle. 72-degree angle is bigger than a 61-degree angle. So that means JK is greater than MQ. Everything else was identical. The bigger angle gave you the bigger side. If you wanted to say MQ is less than JK, that would be correct as well. Okay. I am taller than my son, but my son is shorter than me. Means the same thing. I almost screwed up and said I'm taller than Lidke. I must be dreaming. Now let's use the same idea and compare angles. Hopefully you see two triangles over here. Triangle SRT and triangle TVR. Okay. We have a pair of sides that match, 8 and 8. RT is congruent to itself, so we have a second pair that match. So now we need to look at the third sides. We have an 11 and we have a 6. The quicker among you will notice that 11 is greater than 6. Since 11 is greater than 6, that means this angle, angle TRV, or VTR, as I said it over there, is greater than angle SRT. Since they listed them in this order, I used the less than in that case. SRT is less than VRT. I could have said VRT is greater than SRT, and it's all good. Okay. They're also going to throw at us to find the range of possible values that x could have. Okay. We know the two outermost sides are congruent because we're told so. Okay. And we're told that these two are both 50. So we know for sure how to compare these two things. The 68-degree angle is bigger than the 55-degree angle. So 5x plus 2 has to be less than 47. Okay. So solving that, we find out x has to be less than 9. Now we also know that that side length can't be negative, so we have to consider that possibility as well. 5x plus 2 has to be greater than 0 for it to even be a triangle. It has to have some dimension to it. So when we solve that, we get x is greater than negative 2/5. So the range of possible values for x is between negative 2/5 and 9. Now don't confuse yourself into thinking that this answer is bad because we got a negative number. All this is saying is x has to be bigger than that. It's okay to get a negative here. It's not okay to have a negative length. And we'll wrap this up by doing another proof, just to get you some more experience thinking about how to prove things. Okay. We're given that RQ is congruent to S, or is equal to ST, and we're trying to prove that RS is greater than TQ. And we're not going to trust our lying eyes and say, oh, well, it looks like it is, so it is. Because we know better than that. Let's start from what we're given. Okay. Now, based on the idea that we've been talking about the hinge theorem and its converse, then I want to think about how to get two sets of congruent sides. I've got one set, RQ equals ST. I see the reflexive piece, so QS is equal to QS by reflexive, easy for me to say. So now I've got two sets of sides equal. I need to know how angle 1 and angle 2 compare. Well, earlier in this chapter, we determined that the exterior angle of a triangle is greater than either of the remote interiors. Angle 1 is outside triangle QST. It's an exterior angle, so it's bigger than angle 2 and it's bigger than angle T. So I can say 1 is greater than 2 based on the triangle exterior angle theorem. I think there was probably an inequality in there sometimes, but just by saying that I know what you mean. So now since angle 1 is bigger than angle 2, that tells me line RS is greater than line TQ because of the hinge theorem. The angle is greater, therefore the side is greater. Okay? Piece of cake, right? It's very similar to what we did with the one triangle case. Bigger angle makes bigger side makes bigger angle. You just have to do the extra piece of making sure you have two sets of congruent sides to be able to talk about it. And as always, if you had questions along the way, hopefully you wrote those down. Bring them in, make sure to ask them, and we will see you in class.